Hello, this is just a little intro to the formula sheet. This is gonna be a very quick video, just going through the formula sheet, what you can see here, before you go on to the main review videos. So you have a bunch of formulas. The first group of formulas are all about the mean and the standard deviation, right? And if you don't understand what this means, or right here, right, the X bar is the sample mean, and it says that this is the sum of the x's. In other words, you add up all your data. This big capital letter sigma means you're adding it up. So you're adding up all your data and then you're dividing by n, which is the number of data points. Right? That's how you calculate the mean. Right? Hopefully you knew that from paying attention in class. And this is how the formula shows it. Right? And then the population mean is the same because it doesn't matter if you have a population or a sample. The calculation for mean is the same either way. With standard deviation, on the other hand, we have a much more complicated formula. Right now, you might be able to look at this formula and understand what it's saying you should do. It's saying you take the data, you subtract the mean, then you square that, then you add all that up, then you divide by n-1, then you square root. And that's sort of like the 6 steps. But if you're going to look at this formula and think, oh no, I don't understand what to do, that's okay, right? You just need to make sure when you're studying for this, you know the steps to calculate the standard deviation. And if you watch the review videos that I've done, I lay it out in 6 steps. And so if you know your steps, that will cover you, right? And this formula is just a really condensed way of saying those 6 steps. Right? What this might be helpful for, even if you don't remember anything else, is that the difference between these two formulas is just that in a sample standard deviation, you divide by n-1, and in a population standard deviation, you divide by n. All right, then we have the variance and so on. The variance we mostly just have as a step along the way to getting the standard deviation. So if you watch my video, you'll see we get the variance in step 5 before finally getting the standard deviation in step 6. And then we have the coefficient of variation. I didn't do any examples on this in my video, but if it comes up, you have the formula right here. The coefficient of variation says you take the standard deviation, you divide by the mean, and then you multiply by 100%. Right? So you just standard deviation divided by mean, that'll give you some decimal, times 100 to make it a percent, and there you go. Next up, we have some probability rules. Now we have the probability that A occurs or B occurs is the probability of A plus the probability of B minus the probability of A and B. And the subtraction is to avoid double counting. And you'll see an example of that if you look at my part 2 video where I do the contingency table. You'll see an example where I have to subtract off to avoid double counting. So this is it's called the addition formula usually. This is, we add and subtract to get the probability of A or B. The probability of A and B, if they're independent, you get by just multiplying the A times the B. If they're not independent, then this does not work. The probability of B given A, this is a conditional probability. Given that A occurred, what's the probability that B occurs? You do this, the probability of A and B divided by the probability of A. So that's that formula. And if you were wondering up here in the previous formula, well, what do I do if they're not independent? How do I get the probability of A and B? Well, you can see that's actually right here, and you can just rearrange it, right? The probability of A and B would be equal to the probability of B given A times the probability of A. You just take the probability of A and you multiply it up to the other side of the equation. And that would give you what you would do if you had to get the probability of A and B, but they were dependent. They were not independent. And you'll see an example of that sort of multiplication to get the and in one of the examples I do with the probability tree in part 2 of my recording. And we also use this formula at another point in that question, right? We use that formula a couple of times. Then for normal distribution, we have 2 formulas. One is if you given the x, if you know the x value and you want to find z, you use this formula, x minus the mean divided by the standard deviation. And if you want to find x and you have z, you do this formula, right? Z times the standard deviation and then add the mean. Okay, so use this is really the same formula rearranged. We just did some algebra to rearrange the formula. It's the same formula. It's just if you want to find Z and you have X, or if you want to find X and you have Z. Right, then we have the binomial distribution. You have this formula here. This formula is all good, but we also have tables. We have tables on this sheet for binomial distribution, and you will see how to use these tables in the part 2 recording, where I do a binomial distribution example. Right, just like with a normal distribution, these formulas aren't the whole story, right? You also have normal distribution tables. If you scroll down past the binomial distribution tables, you get to the normal distribution tables. And you'll see how to use those also in part 2 of the recording. And the last thing we have here is empirical rule. This is another thing I didn't actually do in the recordings, but it's just sort of what it says. 68% of the data falls within 1 standard deviation of the mean. 95% falls within 2 standard deviations of the mean. So if you have a question like this, you're going to be doing things like, I'm going to take the mean and I'm going to add 2 standard deviations on one side, subtract 2 standard deviations on the other side, and then I can say, oh, 95% of my data is in that range. Right? And that's what the empirical rule is all about. How much data is within 1, 2, or 3 standard deviations of the mean? This is if you have a normal distribution or data that is approximately normal, right? You have to have a symmetrical bell-shaped distribution for this to be true. If your distribution is not symmetrical and it's not a bell curve shape, then this is not going to be a good rule to use. It's going to give you the wrong answers. Right? But for symmetrical bell-shaped data, this is going to give you pretty accurate answers. And that's what we've got on our formula sheet. So that's it. That's just a little intro to the formula sheet. And you can move on to the other recordings.